Good morning. Today we will be doing a creature feature on the blue marlin. My name is Matt Carberry, and bear with me because I am sick as a dog. Alright, here we go. So in this presentation I will be talking about the general background, the facts, classification, location, migratory and predation tendencies, predation video and case study, effects on food availability and ecosystem interaction, and then some closing statements. General background. So its name is a blue marlin. It's a Macara nigrigan. It's a fish. It likes to eat meat. Its group name, it swims in schools. Its average lifespan is actually interesting. Females are 27 years and males are only 18 years. It can grow up to 14 feet and almost 2,000 pounds, and as you see below, the fish's size compared to a 6-foot man is a lot bigger, so I wouldn't mess with these things. Females are considerably larger than males, sometimes up to 400 to 500 pounds larger. They are the largest of the Atlantic marlin and one of the biggest and fastest fish in the world. And on the IUCN Red List site, its status of species is vulnerable. Over the years, we have seen, scientists have seen rather, a decrease in population. This can be due to climate change, food source shortages, and also, reproductive issues. So some facts. So actually, the flesh of blue marlin is very good quality. It's marketed and prepared as sashimi, and sometimes you'll find it in Japan as a sausages. Macaragans also are among the fastest and strongest predators in the entire ocean. It's an athletic billfish, and it dominates the food chain in tropical and temperate climates. Females release millions of eggs in hopes of a male coming into contact, and the eggs are free floating within the water column. So if they're not picked up, they're just going to decompose over time, and it's kind of sad, but that's how they roll. And their predators are actually mako sharks. So as you see below, you have a big mako shark and a blue marlin heading off, ready to get it on. Usually the makos win because they can catch up behind a blue marlin, and they grab it by the tail and then work its way up the body. There's videos on that on YouTube if you're more interested in that. So classification. So its kingdom is an Animalia. Its phylum is a Chordata. Its class is an Actinopterygii. Its order is an Exiphiformes. Its family is an Istiophoridae. Genus is Macara. So when you look at it, it's got a cobalt blue along the top of the fish, a silvery to white belly side, with a pronounced dorsal fin and long, lethal, spear-shaped upper jaw. It has 4 total gill openings on the sides behind the eyes. Now, as you look at this fish, note over years of history of studying these animals, researchers have divided these two species into multiple different species, but recently studies have shown, genetic studies rather, that scientists believe that all blue marlins have around the same species. And also in the order, it's similar to a swordfish, and its family distinguishes it as a billfish, but it's in the swordfish order. All right. So its location, it ranges over tropical and warm temperate waters of Pacific, Atlantic, and Indian Oceans. In this photo by Noah below, it shows the geographic range. So in the eastern Pacific, it's found from California to the southwestern central eastern Gulf of California all the way to Peru. In the Atlantic Ocean, adults are commonly found in tropics within the 24 degrees Celsius isotherm. In the eastern Atlantic and Pacific, blue marlins concentrate in more shallow waters than in the western part of the world due to the hypoxia-based habitat compression over oxygen minimum zones in the eastern tropical seas. So this basically means that they swim closer to shore in less oxygenated waters rather than deeper in oxygen minimum zones, is basically what it's getting at. So their migratory tendencies. So I put this picture back up here from NOAA. As you can see, that they are literally found everywhere along the in the regions of the equator. On the right, there's a table from a marine biology book by Block, and they basically tagged 6 blue marlin fish of different weights and estimated how far they traveled, how many kilometers they traveled over a duration of time. And as you can see, the largest blue marlin, weighing approximately 220 kilograms, traveled 253 kilometers over 67 hours. So that guy went on a little vacation. All right. So they have seasonal migrations, which carry them thousands of miles over different ocean basins, as you can see highlighted in orange in the picture. And their vertical and horizontal migration tendencies really only apply to basins that are along or near the equator. And actually, in an article that I read, they tagged a couple marlins in Hawaii, and they showed that they consistently migrated south and southwest, crossing equators. During La Nina and El Nino events, these fish sensed a decrease in vertical habitat due to unfavorable water columns from these events. This basically also resulted in a decreased density of the species in more affected areas. So basically, they can sense climate change, and they move. They completely change their migratory tendencies. All right, so predation tendencies. So they feed on octopuses, squid, other pelagic species as well. The way in which they feed can affect available food sources for other organisms that feed on these same sources. They use their spears and swim rapidly into dense schools and return to eat the wounded or killed prey. So it's kind of like a no mercy like hunting, and it fits perfectly with their character because they're a very aggressive fish, or billfish rather. So in this article by Maris et al. 2015, they evaluated swimming speeds of predator to prey interactions with billfish that are similar to blue marlin. They measured this using high-speed video and triaxial accelerometry up to 70 miles off the coast of Cancun, Mexico. And basically what they found was that blue marlin generally swims slower for the greater portion of time. I think the number was 93%. And the other 7% was short bursts of speed that made them so effective in catching their prey. So their cruising speed was at around 2 to 3 meters per second, which isn't slow, but their bursting speeds were 7 to 8 meters per second, which is a lot faster. And there'll be a video to follow. But this article proved how unique their methods of predation were and how efficient they are at conserving energy. They're definitely very smart animals. So as you can see here, this is a video of their predation habits. Not this one. So there's a blue marlin. As you can see, it's chasing this swarm of, I think it's mackerel in this video. But so you can see how they kind of drift, and then they shoot at the school of fish. Right there, you can see that guy just got chopped in half. Beautiful. So they'll do anything they can to get these guys. He stuck that little fish on right on his spear, and that's a very common occurrence in the predation of these animals. They will stick basically anything if they get it in the right spot. take it to the surface of the water, suffocate it a little bit. This guy was lucky enough to get away, though, as you can see. You see it swimming off the screen right now. Yep, there he goes. All right, so the pelagic Pacific food web. So basically, this is just showing how high up in the trophic level the blue marlin species is. They are right along with sharks, other billfish, and swordfish, but as you can see, there's lines going from these guys to almost anything. They'll eat the epipelagics, other squids, flying squids, skipjacks, small scombirds, even mahi-mahi, and also yellowfin as well. Basically anything that they can get their spears through or catch up to, which is pretty much everything, they will eat. So ecosystem, food source availability, and effects. So upon arrival of a migrating blue marlin, an ecosystem or a herd, a school of fish, there's low stress, there's an abundance of them, everything's good. But during arrival of a blue marlin, prey is stressed. Ecosystems may even see a loss in biodiversity as a result of mass amounts of prey being eaten. These are big fish. They're up to 2,000 pounds. So they will eat a lot. Pounds and pounds and pounds of fish every day. So it resulted to billfish to ecosystem interactions. They include prey loss for other organisms, trophic level overlap, which can kind of confuse different species, and they force prey changes for other species and higher stress for species as well. So closing statements. So trophic variations, I think, should be better understood. Blue marlins' migratory tendencies, they actually follow climate change trends with El Nino and La Nina events. Their predation style is unmatched within similar species and sizes of billfish. They're actually a threatened species, so in my opinion, we need to lessen the bycatching of this fish. It's decreased in the past couple years, but the population size is still on the downward track. And also, more research is needed. They need a better research trends in size, distribution, life history, ecology, their uses, livelihoods, harvest points, population trends, and harvest level trends as well. Now, before we go to work site, I would like you guys to see what happens when you go fishing for one of these things. This blue marlin stuck this guy while they tried to pull him up on the boat while he was hooked by a fish hook. I found this off of a marlin forum from fishwrecked.com, and you can see this guy's leg is just completely impaired by a spear of a marlin. So I wouldn't mess with these guys. These are my works cited. Any questions? Comments?
Applause?
Nope. All right, thanks.